So good morning everyone gathered here. So I am Dr. Mannivanan, working assistant professor in computer science engineering department. So going to handle the data structures and algorithm course. So this course is for 3 branches. It's a very basic computer science course. So data structures is need for computer science students, ECE students and it's electrical students, right? So I welcome you all for the video lecture of the data structures and algorithm. So today we are going to be discuss about what is data structures, why do we need data structures, what is the usage of data structures, and what are the various classification and types of data structures, and what are the various abstract data types used for the data structures. That is we are going to be discussed here, right? So the first we start the course is what is data structures. So we have all as a data. So we have to provide the organizing, storage and providing the facility to store the data. So whenever you want, you have to retrieve the information, that is the data. So the various way we are storing and organizing data is called data structures. So before data structures, what is data? It's a collection of information. So whatever you want, you can store as a data. Whenever you want, you can take in the data from the system. So that is called the data structures. So a lot of algorithms and applications for the development of the implementation of data structures. That is we are going to be discussing here. Right. So we know that there is 2 kinds of memories there. One is a main memory, another one is a secondary memory. So the data are stored in a computer system in both the memory. So we have to develop, implement the data structures to store and retrieve the information from the secondary memory as well as the main memory. So one of the famous author in data structure, that is Merriam-Webster's defining the way how we are going to be storing and retrieving the information, that is type of data structures. So one is we can easily store as a contiguous the sequence locations of data. So you have memory, have start with 0. So each and every data is stored in 0, 1, 2, 3, 4, 5, 6. There is no omission of any memory location. That is called the linear storage of data or sequential storage of data or contiguous storage of data. The another way is a non-contiguous, non-linear. You can store anywhere. With the help of the pointers can easily link to the particular memory location to the particular data. That is non-linear. So comparing to the linear data structures, the non-linear is an efficient one. We can easily store and retrieve without any hesitation, without any intervention of the data. We can easily finding the data whenever you want. That is done by Merriam-Webster's. So what about algorithm? So this is a problem solving technology. So when you are given some particular question, you have to find the solution with a finite set of the elements and the procedures. So for example, if you are going to be add a plus b, so 2 data a plus b, you are going to be finding the value for a plus b. So what is the procedure? Once you have to take in the input for a and then input for b, then we have to add both the data and we can get the value. So within a finite set of elements, we have to provide the step-by-step procedure to identify the solution. That is called algorithm. The Merriam-Webster's is defining the algorithm. So what is that? It's when you are asking the question, the procedure will provide you the answer. When you are asking about the problem, we can provide the solution. So that is the way of definite algorithm. So this is the 2 kinds of algorithm we have. One is non-deterministic, another one is deterministic. So non-deterministic algorithm is a random input we can randomly access. It's not going to be accessed step by step. We can easily finding any kind of data to the algorithm. So it's a mathematical formula, it's a one kind of algorithm. And when you are asking about yes or no questions and boolean questions, it's also one of the algorithm. For example, if the given number is prime number or not, so we have to immediately check the providing input is a prime or not. We have to check it out, right? So the algorithm is given you the solution whether the given number, if 2 is a prime number, then you have to find the help of the algorithm, problem solving technology, you can easily find whether the given number is prime or not. So now the types of data structures. So lot of classification of data structures. First one is a primitive or non-primitive data structures. So what is primitive? Is a basic data structures provided by all programming languages like C, Fortran, Pascal, Ada, all kind of object oriented programming and procedure oriented programming. So every programming language is providing the primitive data structures, which is very basic. Already the programming languages have the definition. The user cannot going to be modify or change the definition of that primitive data structures. So float is one of the data structure, primitive data structure. Integer is one of the primitive data structures. So from the primitive data structure, we are going to be deriving some data structure that is called non-primitive data structures. So non-primitive data structure is a derived one which is taken from the definition from the that is primitive data structures. The another one, it's a homogeneous and heterogeneous. So homogeneous is a collection of similar data items. So when I am going to be using of integer a, so all the array is using that the array is a integer type. So that is we are going to be using homogeneous. Heterogeneous is a collection of different data items. We can take on one data from integer, another data from float. So floating point value is for example 3.5, which is decimal. So integer value is a whole number, we call it as integer. So when you are going to be add 3 plus 3.5, it's a heterogeneous collection of data items, right? So we will see some example, that is integer a is equal to 5. So integer b is equal to 6. Then we are going to be adding integer c is equal to a plus b. So which is very simple code in C, right? We are going to be adding 5 and 6 and the value is going to be storing into C, right? So now this is a, b is both are integer, that is int is called it as integer data type. So b is another data item, another variable which is also going to be an integer data type. So both are same data type, so we call it as that is homogeneous. So when you are using this kind of this is integer, so now we have integer a is equal to 5 and the another data item is float b is equal to 5.5. So now we are going to be adding the two different value a plus b. So what happens? So a is from the data type of integer which is a whole number and b is a floating point data items which is a 5.5. So now we have two different data items going to be adding and the value is going to be storing into C, right? So when you are storing C of two data items, the value of C is a 10. So why? Because we are declaring C as an integer data type. So which is a whole number, but we need is a 5.5, then instead of integer we have to use that is float. So float value only storing the value of floating decimal point. So 5 plus 5.5, so 10.5 is stored is now in C. So like that, this is called a homogeneous and heterogeneous. And another type of data structure is static and dynamic. So very important in any programming languages like C. So when you are compiling the code, when the compilation is done by the compiler, the memory is allocated for the particular data item. So that is done by static data structure. For example, the integer a is equal to 5. So integer values occupy 2 bytes for a. So this at the time of compilation, a is getting the memory, it's a 2 bytes, then it's a static data structure. So whenever as the time of execution, when the program at run, when a is equal to 5, b is equal to 6 is getting input, then we are going to be executing at a time. At the time we are going to be allocating the value, that is called dynamic data structures. So dynamic data structure is an efficient one which is not wasted the memory. We can, when the execution are there, when the type of data is given as an input, then we can easily find the memory. The compiler can easily identify the memory location and performing some manipulation. The last one is called it as linear and non-linear. So linear is a sequential access. When you start by 0, it's going to be 1, 2, 3, 4, 5. It's a sequential manner, one by one. There is no omission of any memory location in the structure. But non-linear, as I told you earlier, that is going by as linked by the pointers. It's going to be linked by various memory location which is non-contiguous, which is non-sequential. For example, 0 is stored in one memory location, 5 is stored on another memory location. With the help of pointer we can link these two. That is, we are going to be seeing the data structures type. So now the very important concept, that is ADT, abstract data type. So what is abstract data type? Which is having the set of operations. So I am a user, consider and let I am a very uneducated pupil. Now I want to execute some my manipulation, for example summation. I have a calculator, I am going to be adding given two value 5 and 6 and add. It's the result will be given 11. So I don't know how this addition is performed. So that is called ADT. The user doesn't know about the implementation, only view about the set of operations. So the mathematical abstractions is given by the ADT and you can execute of the various manipulation providing by the ADT, that is called ADT, right? So whether the several simple ADTs are there, it's an integer, real value and boolean and character, pointer. So everything we have to use on this very simple ADTs. So integer is 2, right? Integers occupy 2 bytes, but we don't know how the integers occupy 2 bytes. Only the programming language providing the data type integer, that's all. We don't know how this 2 bytes is going to be occupied. So that is why they are called it as several simple ADTs is providing by the any programming languages. So now ADT, in simple words, so what is ADT? It's a set of operations which, as for example, it's a manipulation of some summation or addition, or it may be a multiplication, it's a division, subtraction. So all arithmetic operations can be provided by the set of operation. Doesn't know about the implementation of how they are going to be add or divide or multiplied or subtracted. So it's a definition in some very simple words. It's a set of operations which has a mathematical abstraction, no implementation in detail. The user doesn't know about how the operations are implemented. So very simple ADTs we are going to be seen here in data structures, that is list and set and graphs and tree. So lot of simple ADTs are providing with some kind of set of operations. Right. So why we need ADT? Why all the programming languages is providing ADT? So the first very important feature of ADT is a modularity. We can divide the problem. If you go by arithmetic operations, there is 4 preliminary arithmetic operations. It's a summation, division, multiplication and subtraction. So 4, it's divided by 4 modules. So each of the member can be develop the code for the 4 different things. We can easily merge in that. So will given as a result as a consolidated arithmetic operation. So when there is any problem on the particular manipulation, we are extracting the same. There is addition. If a problem of the coding of addition, we are taken the only code by addition, we are not touching to the another, it's manipulations, that is subtraction, division, multiplication, we are not going to be touched. So very easy to debug, very easy to rectify the error from the code, and very easy to modify. If you want the additional feature, your particular module, we can easily going to be adding some features to that the particular code. Then the another important work is reuse. So for example, we are going to be adding for 10 additions. So A is equal to 1 to 10 and B is equal to 1 to 10. We are going to be adding the several addition. We don't need to be perform the same operations once again. We are already defined the addition. So again and again we can reuse the same code for to be executed. So that is another feature of reuse. Then it's very easy to change off the implementation. It's a very transparent. We can easily going to be changing. We can modify. So the ADT is providing very high significant results once you are using the programming languages like C. So the first one we are going to be discuss, it's a list ADT. So the 3 ADTs are that. So here the first one for ADT we are go by its array. So what is array? So before going to be discuss about list, we need to be know about the arrays. What is arrays? So when you are declaring array, it's an indexing item. So this square bracket is called it as index. So index means which is the inside the index we are defining the size of array. So which is the contiguous. So when the memory location is start for it's 0, the 0 is a memory location or 1. So 2 is another 1, 3, 4 and 5. Right. So we are starting the first letter. For example, integer a of 5 is equal to it's 1 comma 2 comma 3 comma 4 comma 5. So 5 elements in array. Array is an indexing item. We can store the capacity up to the 5 elements. The indexing started with 0. It's a memory location. So this is indexing. A of 0, A of 1, then A of 2, then A of 3, then A of 4. So there is 5 elements. It's an indexing started with 0. In C always the indexing start with 0. So it's 1, 2, 3, 4, 5 is an element. So 1, 2, 3, 4, 5. So the sequentially first 1 it's storing the location in first location, and 2 is storing in second location, 3 is storing third location, 4 is storing fourth location, 5 is and so on. So this is a contiguous memory allocation. When the compiler executing this statement integer a of 5, so totally integer occupy 2 bytes. So 5 elements, totally 10 bytes is allocated for a of 5. So inside that we can easily store 1, 2, 3, 4, 5. So list can be implemented via array. Array is a derived data type. Arrays can be derived from primitive data type. Array is not a primitive data type. It's a non-primitive which is taken from integer now, which is the very homogeneous similar data items can be stored in a of 5. So instead of this, if I am given integer a, so what happens? A is having only one integer value which is have 2 bytes, but I need 5 elements. We are going by array. So array is useful for the homogeneous data items, so similar data items. So you can store any number of data items which is very similar data type. But what is the difficulty in, what is the disadvantages on this integer? So the capacity, once you define, you cannot change again. It's a of 5, only a of array is to be stored on 5 elements. There is no additional element to be stored in array, and it's a waste of memory if 5 elements or your capacity are created, but instead of 5 you are having only 2. So another 6 bytes are wasted, because 1 and 2 is having need only the 4 byte to be stored. Another 6 bytes are wasted, you are not using for any other purpose. Is always is a constant allocation to for the particular array. So there is list is a ordered data items. Ordered sequence of elements is ordered data items to be stored in the list. So we can call it as A1, A2, A3, AN is a list of size of n. So what is the size of list is n. So n is a number. Here we can use 5. So 5 is a size of list. So what is the first element is A1, then A2, then A3. So the size of empty list is 0. It's a null. If there is no size, there is nil. You cannot store any data to the empty list. So A plus 1, AI plus 1, it succeeds AI. AI minus 1 is precedes A of I. That is, it's the next one and the previous one. If you have taken 3, right, so the preceding by 2 and succeeding by 4. Right. So when you are going to be finding, we know only one element, but you want to identify the preceding succeeding element, you can store by the A minus 1 and A plus 1. So like that we are going to be using that. So what is the position? That is AI. So what is the ith position you are going to be storing, which is represent the index, that is 2 for the particular 3. So first element we call it as head, the last element we can call it as tail. So this is a head, the last one it's called it as tail. So why we are defining head and tail? What is the first element we need to be identified? Because this is a contiguous memory location. From the first element only we can identify all other element. If you want to search the element 5 in the array, first you have to find the head of the list or head of the array, the one to be identified. From that you can traversal the next one, the next one, next one, and the final one. So we need some linear cost of time for searching the particular last element in array. So this is very simple array. The size is 5. Consider we have A of 100. You want to find the 100th element. So you have to traverse from 1 to 100. So what is the cost of execution? It's linearly on linear cost. It's a O of n. Up to the size of array, we are going to be searching that. So big O of n is the execution time of the array searching. So big O is a notation to be using for the time execution, the response time execution. So how much time is needed to be identify the particular element in array? So there is a only disadvantages and difficult in the list ADT. So what are the operations is performed on the list? We can perform many operations. That's why we call it as a ADT. Lot of operations. So when you want, you can perform. Make empty, that is a list having 5 elements, but you can empty. So within a single operations, you can easily delete all the elements with the help of make empty operations. And print list, we can printing the elements from 1 to 5. So how many number of elements are there? You can print via print list operations. Then finding the particular number, finding with given by the value, data items, find 5. So we can easily finding the element, and find kth element. So find kth element is a particular position, what is the element are available. In third position, what is the element? Via find kth operation, you can easily find via the position. Then inserting the element to the list and deleting one element from the list, and what is the next element, what is the preceding element or succeeding element. So everything can be done by the operations on list. Right. So this is very simple example what we are given already. So which is have the 5 elements, that is 34, 12, 52, 16 and 12. So this is a list which is occupy the contiguous memory location. It's a sequential memory location. Now the operations is performing for find 52. 52 is a data element. So we know only the data element. We don't know what is the position of the 52. So which is the algorithms to be executed. The operation is executed find 52. It's searching from the first one. It's a 34. 34 comparing to the key value 52. If it is not matched, then it's moved to the another location, the second location. Then 12 is another one. So 12 and 52, it's not matches, which is not equal. So it's again traversed to the next location, 52. So 52 is equal to 52. So its matches occurs. So what is the position? That is 1, 2, 3. So third position in the list 52 is available. So the position third it's to be an output for the finding operation. Now what we are going to be performing, inserting 20 is a data item, it's a value. it's a fourth place you are going to be inserting 20. So what has happened? 34 is first, 12 is second, 52 is third, then the fourth place is now is 16. So instead of 16 we are going to be inserting 20. So what we have to do, the insert operations is performed finding the particular location from the beginning of the list and the particular position. If the elements are there, then we are going to be moving the element into the next position if the capacity is allowed. For example, if the list is having only the 5 size, the size of the list is 5, you cannot perform insert operation because already there is a 5 elements. If the size of the array is 10, then you can easily insert 20 as a fourth place. So 34, 12, 52, now the fourth position is 16. So now we are moving to the fourth position to the fifth position. So 16 now in A of 4. So now the 16 is going to be on A of 5. We are moving the data to the fourth position to fifth position. So makes the empty of A of 4 is a position. Then only we can easily insert 20 to the particular position. So after inserting 34, 12, 52, now the inserting 20. So 16 is moving to the next position is a fifth position and 12 is in sixth position. That's why size of now the length of the list is 6 after adding 20. So now we are going to be deleting the 52. So deleting 52, we have to find where is the exact position of 52. The first one is checking from the linear. So first element is checked, 34 and 52, it's not equal. Then 12, right? Then it's not equal. Then 52. So now it's matched. So now we are going to be deleting the element of 52. Then all other position data to be moved previously. We have to proceeding the data from the previously because A of 3 is 52. Once deleted, there is no value for the particular position. But there is another 20, 16, 12. So list is implemented by array. It's a contiguous memory location. We cannot omit the particular position. So we have to move 20, 16, 12 into the previous position. So initially 20 is a fourth position. After deleting 52, it comes third, 16 comes to fourth, 12 comes to fifth position. Now the length of list is 5 after deleting 52. Now find kth. What they are going to perform? K is a position. So what is the element in third position? So the first find, it's performed by data elements 52, but this find kth is by the position. We don't know the element, but we need third position. What is the element is that? There is a possibility in list ADT, that is find the position in the third in the list. So first is 34, 12 is in the second, 20 is the third, so it's written the value is 20. So this is some simple basic operations we are performing via list. So what are the drawbacks on this list? We can easily implement it via arrays. It's a contiguous location. Otherwise we can go for linked list. Otherwise we go for cursors. So three basic implementation on list. Array implementation is a contiguous. Linked list is a non-linear data structures which has the linked by the pointers. So here the pointer concept are introduced to be linking of the different data elements storing in a different memory locations. The cursors, which is not uses the pointers, which is not uses the memory allocation operators like new or free. The new and free is a memory allocation predefined operators which is very slowly perform of allocating the memory and freeing the memory. But cursor implementation, it's to be using linked list, using of arrays. You can, instead of pointers, we are using arrays to be implemented list. Right. So what is arrays? We already discussed what is arrays and what are the difficulties on arrays, how the arrays are allocated, which is contiguous, which is homogeneous memory allocations, right? So all the things, all the same data type we have to perform on array. So this is consecutive. The length is for all the particular array and which is created at the definition, then it cannot be changed. That's all we already see, right? So this is a O of 1 is a constant time. So this is a response time analysis or is a time constraint. So whenever the algorithm is created, the very important, the execution time of the algorithm. For example, A plus B is 5 and 6. We can easily say by O1 by the human it's 11. It's fraction of seconds we can easily say 5 plus 6 is 11. But you are writing the algorithm for manipulating 5 plus 6, which takes to be on executing this code in more than 1 minute. There is no use of writing algorithm. So within very fraction of second we have to calculate. That's why we need a manipulation, we need automation. So this is array. When you are consecuting, you are going to be using that. The constant time it taken, you are searching, you are inserting, you are deleting, which is start from the head of the list. So the first element should be identified, then only we can perform all the operations in array. So the constant time to be needed for finding the head of the list, then only we can perform the different kinds of elements, right? So different types of array are there. So one dimensional, what we see is one dimensional. So we can now use of different data types of arrays. So first one is one dimensional or single dimensional. So integer is a data type which is provided by C. It's a, it's a variable. So now we are using 5. So this is a very single dimensional. So I already told you this is indexing. So what is index? When you are go by the searching for some books, you are taken some textbooks. So when you want to search something, you are going to be viewing the index. So which topic in which places? That is indexing, right? So all the lower bound of C is started with A of 0. So A of 0 is position. A of 5 is a capacity of array. The 5 is denotes the capacity of array, 10 bytes. For individual A of 0 is 2 bytes, up to A of 4 we can 10 bytes. This is called indexing. This is single dimensional, only one index or there. Go by multi-dimensional or it's more than one dimensional. A of 5 and A of 5 is a two-dimensional array. So this is A of 0 and it can be A of 1. So two different dimensions are used, two indexing are used here. If I go by matrix, for example 3 cross 3 matrix is 4 2 4 and 5 6 4. Now this matrix is going to be using as a manipulation. Single dimensional is not supported to be stored here because this is a row and column. If you are going to be identify the 3, it's in a row it's 1 and column is 1, the first position. So we need two indexing to be identify the matrix. So in kind of matrix manipulation, matrix addition, matrix subtraction, we go for multi-dimensional, which is of the same type but more indexing or that is a multi-dimensional. And static array, the allocation of memory for this array creation is done in compilation. So when what is compilation, what is execution? When you are compiling, the compiler, C has a compiler, the compiler check whether the system and semantic rules are maintained in your program or not. If there is a predefined integer or that, what happened? Integer A of 5, first the compiler understand what is int, that is integer. What is integer? Is a primitive data type which is allocated 2 bytes. So immediately compiler what happens? Go and search in the main memory if there is 2 bytes is available or not. If there is a 2 bytes, then is allocated for A. So that is done by compiler. At the compile time we are going to be allocating the memory size to the particular declaration. That is called the static array. The dynamic array, memory allocation is done as an execution. At the compile time we are not going to be using that. When the input is given, for example A of 0 is equal to 1. So the A of 0th position, the data value is 1. At the time when you are given 1, at the time is going to be allocating the memory for A of 0, that is for dynamic array. So instead of you are using static array, you can use always dynamic array, then the efficient memory we can perform. So memory is very low because 1 GB of RAM we are having. We are performing several manipulations. So we need to be optimize the memory. So when you are optimize the memory, you have to use for dynamic memory. Don't waste the memory while you are writing the code. So this is one dimensional static array is a syntax. So what we see, the element type we have the integer and the array name which is have the name of array is A of 5 and the capacity inside the square brackets you have to given the capacity. For example in C++, int is an integer, b is a array name which is the capacity of 5. So integer p of 5, what happens? B is an array having 10 bytes of value which can store 5 elements. So if what is the 5 elements? 19, 68, 12, 45 and 72 we can easily store. So b of 0 the value is 19, b of 1 the value is 68, b of 2 the value is 12, b of 4 is 45, b of 5 is 72, like that. So indexing start from 0 as always. So when the capacity of array is 5, it's starting from A of 0 to A of 4. Right. So this is a list implemented using array. It's a schematic representation. Very simply you can understand how the list is represented via array. So this is, you know, that list is an ordered element. So ordered element means it's ascending order. So 2.3 is a data, 7.1 is a data, 0.3 is a data, 9.5 is a data. It's not an ordered element because 0.3 is placing 2, is an unordered list. So list can be implemented by two types. One is ordered, another one is unordered. This is the order of elements but the value of the data elements is not ordered. It can be 2.3, 7.1 and 0.3. 0.3 is very less than 2.3 and 7.1. So this is unordered list. So what is the size of this array? It's 4, only because 0, 1, 2, 3 we are having 4 elements. All the other elements is 0. Still we are not getting the values. So capacity is 10. You can store up to the 10 values, but actual length is 4. That's why I told you. So this is the biggest disadvantages of an array. We need only 4 elements, but we are occupying the memory. It's 4, 5, 6, 7, 8, 9, which is no value on that particular location. So the another 12 bytes is wasted for here for occupying the memory. So this is a very simple implementation using array. So this is B of 0, B of 1, B of 2, 3. C is a programming language providing the index of any array is started with the index 0. So index is 0, value is 2.3, which is have some memory location. The memory addresses, a physical addresses can be defined here. So what are the operations can be performed list? We already see that. But how we are going to be performing the list operations? The two possibilities. One is we can perform all the operations as ordered or unordered. Ordered list can very simple. When the data is, we are finding the ascending order or descending order, there is any of the orders maintaining the list, we can easily find the position. Unordered list is quite difficult than ordered list because there is no order in an element. So this is insertion we are performing in the ordered list. So what is the insertion? The element 3.25 to be added at the position of 2. Right? So what we are taken 3.25 is a value. It's an ordered list. So why we are going to be inserting the position 2? Because 0.3 is in 0, 2.3 is 1. So checking the value. Now the second position is 7.2. 3.25 is less than 7.1. So this is an ordered list. We have to insert 3.25 as a second location. So 7.1, what is that? Is moving to their succeeding position. So after inserting, what happened? The 2 is a position 2 is having 3.25 and 3 is 7.1. It's moved and the next one is so on. It's going to be moving. So after inserting, what happened? We are incrementing the size of the array. Initially that is 4. After inserting 3.25, it's the size of the array is 5. So this is insertion in detail. So this is what happens. Before we are seeing the example. So insert value in the below array. Right. So 4 to be inserted in the array. What is the array values? 1, 3, 6, 7, 10. So we have the 6, the capacity of the array is 6, but we have only 5. So first, before inserting, the algorithm is going to be checked whether the array having the capacity to be inserting 4 or not. So there is one place is remaining, so we can easily insert 4. Then is ordered list. So checking the value 4 and 1. So 4 is higher than 1 and 3 and 4. So 4 is higher than 3. So then 6 and 4. 4 is less than 6. So we have to insert 4 in the particular third position. So third position we have to insert 4. So what happens? So traversing the array. So third position we mark it as. Then we have to move the element of the remaining element to the next position. From which is we are going to be start from the last of the array. So the last element in the array, it's shifted to the next one, and 7 is shifting next one, and 6 is shifting next one. So now this is, it's free, we can easily insert 4 here. So after inserting, we can easily say a third position, it's a 4 is that. So this is ordered list insertion. So what is how the deletion is performed? So once you are inserting, the size of the array is incremented. So initially 4, now is after inserting is 5. So k plus 1. The data items is k, after insertion is k plus 1. So after deletion, what happens? We have to reduce 1 from the array size. So initially 4, after deleting is to be 3. So two elements, first one is unordered array, another one is ordered array. So how the deletion is performing or unordered array? So what is unordered? 0, 1, 2, 3, 4. So this is maybe the element is unordered. So now what we are going to be deleting the element of this position. So now this deleted, we are going to be deleting. So decrement after moving element. So once you are deleting, how to shift all element into the previous position. So insertion is to be the succeeding position traversing, and the deletion is a preceding position traversing. How to move one by one, it's a preceding to the particular array. So that is tail to head. The tail to head to be moved, but in insertion it's a head to tail to be moved, right? So this is after we are moving that we are decrementing. Initially 4, after deleting is 3. The same is to be performing in ordered list. Is a sequentially we are going to be traversing. So this position is deleted. So now the tail position element to be moved here, then next preceding, then the next one, and so on. Because this position to be destroyed. Because size of the array to be decremented by 1. So after deletion, initially size is 4, after deletion the size is 3. So from tail we have to proceeding the element to the all the previous positions, right. So find and search. So how to be perform find and search? So what are the various way to be find and search? Or find or search is to be a same one, but array it's perform only the linear search. So a lot of searching are available. When you are given by the key element, when you are given by the score, we can easily identify. So if 1, 2, 3, 4, 5, 6 is an element, you want to find 4. So you have to given the scope, but what way you have to perform? So two kinds of searching are possible. One is linear search, another one is binary search. For this linear data structure like array or list, it's to be performing the linear search. So what is linear search? It starts from the first position and it's a succeeding position to be identified with the help of the key. So if you are given a key find 52, we are going to be searching and comparing the value. If the values are there, it's returning the position. If the values are not there, it's returning -1 because there is no value. So what is the indication? If the -1 is received as output, then there is no element in your list. So that is a very simple thing. They are performing the linear search. So the very simple example what we taken to find 25 in the list. So list is a contiguous. We have several elements. So it is from the 12 elements in the particular list. So we have to find the head of the list. So 25, the head is a of 0 is 3. So each and every value is compared with the position. So 3 and 25, then 15, 2, 8 and go on to the end. If the 25 is not in the element, what happened? It's stopping the algorithm, stopping the execution and return the value -1. So when you receive -1, the 25 is not in the list. Right, so that is a linear search. Start from 0 and 1, 2, 3. So this is the linear search having the biggest disadvantages. We need 12 elements is okay, but we have the thousands of elements, of millions of elements, but 25 is not in the list. You're going to be traversing up to the millionth element to be compared by the particular list. So what is the execution time? Is a O of n. So very long time is needed to be tell there is no element in the list. So that is the biggest disadvantages. Sorry, it's a disadvantages in linear search. That's why they go for binary search. So this is a function is returning as a C. So integer is a data type int. In a C programming, int is a data type. So data type which is has a set of values is a whole number which is has a data representation. Whole number is a data representation and the operation is a linear search. So what are the parameters is passing to the list? That is integer a of array. So it's unlimited. So once you are not defining any capacity to the indexing operator, it's an unlimited value you can store. Any number of values you can store into the array. That's why we are not defining any capacity, right? So there is no constant value. Unlimitedly you can store many numbers. So integer n is the size of array. The key is going to be a searching value. So a is array, n is a size, key is a what value you are going to be searching. So three parameters for linear search. So when you are executing this linear search, it's for iterating variable. We are declaring I because of iteration used in for loop. It's a repeatedly we are going to be checked because it's a 10 elements or that starting from 0 and moving to 1, 2, 3, 4, 5. So recursively we are going to be checking from 0 to 10. We need a for loop, right? So for loop is iteration. Several iteration we have to perform. First 0 and which is the condition to be less than n. Up to the size of array you can checking the value less than n, which is to be incremented after the execution. So initially 0, a of 0 to be searching for the key value. A of 0 is equal to key for easily 25. 25 is our key value. 12 is a size. So a of 0 is 3, right? So a of 0 is checking with the 25. But what is the actual value in a of 0 is 3. So which is not match. So else spot, right? Then it's going to be a iterating of incrementing 1. So now I is equal to 1, a of 1. So what is the value in a of 1? It's 15. So now 15 is compared to 25. There is not value. So again incremented. When the conditions are true, when the condition are satisfied, up to that this for loop is going to be using. So when the condition is false, when it's up to the end of the tail, after that the incrementer there is no size, only 12 elements. If you go by I is 13, the condition is automatically false. So it's exiting from the loop, it's written -1, there is no value in your list. So that is a linear search function. So this is an explanation what I am given is in the presentation. So a is array and n is a size, and item is what item you are going to be search, the location, which location is going to be finding here. If there is a location, then it's written the particular location. So when finding the particular element, it's written only the location. If it is not, it's going to be returning -1. So this is a printing list of operation. What are the element is there? I want to see that. You want to display to the list element of the list. The element of the list on my array, it's 19, 68, 12, 45, 72. How to display on that? So particularly we need to be defining the for loop. The integer I is iterating value. I is to be as a type of integer 0, and which is less than 5. Only we have the 5 element. So first 0 is less than 5. Condition true. Then it's going to be printing my array of I. So 0th position 19 is printed. Now it's incremented by 1. I is equal to 1. So 1 is less than 5. Condition satisfied. It's listing the first position 68. So when is 4 less than 5? Condition satisfied. But when the condition it's incremented is 5. I is equal to 5. 5 less than 5. 5 less than 5's condition is false, so exiting from the loop, then only the available elements to be displayed. This is print list. So now the insertion is performing on the implementation. So this is k is item count. How many elements are there? We are representing k. So this is a indexing 0, 1, 2, 3, 4. So now after inserting, very simple, which is already seen. So after inserting, we are incremented the item count is k plus 1. So initially k, after inserting k plus 1. K is equal to 10, after insertion it's 11, 1. So what has happened? We have to always inserting, it's you are not given the position, it's to be inserted at last. Understand? So when you are not given the position for the particular elements, so 12, 3, 19, 100 is up to 18 we there. So now we are going to be inserting 44, but you are not representing, you are not denotifying the position. What happened? Array is automatically inserting element at the last position. So last position inserting, there is no need of moving the elements. So there is a last position we are inserting, then it's incremented is k plus 1. So this is implementation of deletion. Initially is k, but after deleting we are going to be a k minus 1. So it's proceeding. So when you are deleting the element, so now you are going to be deleting the element of the third position. What happened? You have to move this 100 to the preceding location. So from the last we are going to be moving the position up to 3. So after that the deletion, it's a k minus 1 should be an item count for the list. So this is the running times, the execution time of the particular operation. What are the operations we perform? That is printing list, find, insertion, deletion, find the position, next and previous. So what happened? This is big O. It's a notation to be given by the optimization of the execution. So when the compiler is executed, we can notate via O. So n is size of array. It's a maximum number. So printing list and finding, we are traversing through the list from the beginning. So that's why we are given by n. It is a size of array. So from the beginning head to tail. So every element to be examined to be printing the list and finding the element. So that's why we are denotifying O of n. Insert and delete is also, we are starting from the head and we are going to be inserting at the last and deleting in middle. So which is also having O of n notation for the running time of operation insertion deletion. But finding kth position, next and previous is a single operation. Finding kth position, what happened? We can easily traverse to 3. We don't need to check any items in 1 and 2. Find third position, we can traverse up to third. So single constant time is needed to be moving for third position. Like next, if you are in one element, what is the next element? So only one execution is needed for the particular element. 1, now next is 2, that's all. Like previous is now 2. What is the previous? Is 1. So that's why we are denotifying the notation is O of 1. So O of n is for print list, find and insertion and deletion. O of n is find kth, next and previous, right? So now what are the disadvantages using array for representing list, implementing list? It's need to be defined the size of array, which cannot be modified. Once you are defining size is 10, it's always is 10. So you need only 3 elements. All the 7 position are still waste. So memory waste, high overestimate. You are given 100, but the item is 3. All the 97 elements are to be waiting for the. You do not be using for some other purpose for the memory location. It's entirely it's a waste of space. Then insertion and deletion is very slow. Because to start from the beginning, you have to find the particular position. To be finding the element, checking the element, then how to moving entire element. For example, if you are going to be deleting the first element, consider you are going to be deleting the first element. If you have the array is 100, so 100 elements are in array, you are going to be deleting the first element. What happened? For all of the 99 elements to be shifted to previous. So 99 shifting is needed for the deleting the first element. So which is very slow, you are going to be deleting that, right? So then it's a redundant memory space, lot of memory to be using that. So this is very difficult. What is the size of array? Whenever you want, you are going to be adding that. So when you are going to be data stored by the particular data type, we are using the redundant array, lot of waste of memory. So because disadvantages of array, it's a waste of memory, we cannot optimize. So when you are consider of implementing the list, you do not go for array, which is cost very simple but the waste of memory. So that's why they are going by linked list, right? So now we are from that, we are going to be seen in a blackboard. So now we are going to be seeing the linked list. So linked list is not a linear, it's a non-linear data structure. So instead of traversing from the head, you can traversing from anything. So random access. If you want to find the third position, you do not traverse from the head. You can going by the particular position, that is linked list. So what is linked list? With the help of the pointers, it's a linking of the different memory locations which is non-contiguous. That is, we are going to be linking via pointers. So one of the types of linked list is a singly linked list, then doubly linked list, then circular linked list. So three kinds of linked list are there. So doubly, singly and circular linked list. So what is linked list? So instead of storing arrays, so this is array which is have 1, 2, 3, 4. So instead of the contiguous, we are going to be using the node, creation of node. So what is node? Which has the two compartments, one is for data, another one is for pointer. So what is the name of this pointer? We can use next pointer. So that means the data is there. What is the next data? Where is the next data? You can easily finding from this pointer. So here first we are going to be seeing the singly linked list. So singly linked list, the node declaration for that, which is have the single node. So two compartment, one is for data, that is A is a data, consider. The next pointer, it's a pointer. So the pointer is pointing to the another node. So which is to A1. So which is this A and A1 is different location. For example, this is the location of 4509. So this may be on 4809. So there is not contiguous of the next element. The first element is A stored in 4509. The next element is stored in 4809. So if it is a lost element, it to be identified. The lost element is a pointer is null. So this is A and A1 and A2. So lost element, how to be identify? The list is completed, list is over. Then we have to identify the pointer part, pointer compartment of the last node, which is denotified by null. So starting from A, so which is how the pointer is 4809. So now the traversing the list to 4809, which is have A1. So which is from the another location 4960. So this is 4960. Now the link is going to 4960. The lost value, because the next pointer is null. So there is no value in this part. This is null. So this is end of the list. We can easily identify this is the end of list. So this is singly linked list. So how to be inserting element to that? For example, we have 5 is a data, and which is in another location is 6, right? So this is 4000. So this is a memory location is 5000. Then which is null value, that is null. So only two elements is there, 5 and 6. So the pointers denotify 5000 and this is null. So when you start the head node, so this is the first node which is called head. So 5, where is the next element? It's linking by 5000. It's go by 5000 memory location. It's in 6, so there is no element, it's null. So how to be insert particular element? All the operation what we are seeing in list, all kind of operations can be performed in linked list also, because it's a non-linear data structure. We can perform. It's a ADT, it's abstract data type. So how to be perform inserting on this linked list? So there is 3 ways to be inserted. One is insert first. The first element you have to insert. Then insert lost. So at the tail you are going to be inserting. And third one is insert anywhere. So insert anywhere, it's between the locations we are going to be inserting. The first two are very simple. The insert anywhere is just what is a complicated comparing to the insert first and lost. So this is the first element. So next element is 6. There is only 2 elements. So now we are going to be inserting the element x is equal to 10. Right, at first you are going to be inserting the element 10 at the first of elements. So what has happened on insert first is to be on this, how to create the node for 10. So new node is created, it's a value of 10, which is on some other location is 3000. So what happened? So this is the first element. So what is now is the first element is 5, which is the address of 4000. So you have to create the pointer to link it that. So now it's currently the head node is 5. So now we are going to be 10 to be a first node. So you are creating 4000 is a pointer. So what has happened? The pointers to be using here. So now, so this is inserted as the first position, 10 is using first position. The new node is created, then the pointer to be mentioned the address location. What is pointer? Storing address of the another location. So this is pointer is having 4000. What is the value of 4005? So now this is a first node, then linking to 5 and 6. So this is inserted first. So the routine what we are going to be using. So what is routine means? Which is to not exceed the 1 pages, which is very compact, very simple. Then we have to performing this operation. So how to insert? For example, void insert. So which is the parameter we have? The element type, that is element, which element you are going to be inserting, that is X. Then which list you are going to be inserted, that is L. So this list is to be L. 5, 10, 5 and 6 is a list L. And what is the key value you are going to be using that? So element X, list L. What is the position you are going to be using that? That is position P. So 3 parameters for inserting element you need 10. What is a list? This is a L is a list. So number of lists are available in a particular data structure. Lot of lists are to be available. So we have to name it as the list. The name of the list is L. Which position you want to insert, whether it's a first position or last position or any of the particular position. So 3 parameters of element and list and position. Then you have to create one node. So one node is to be identified by temporary cell. So this is a temp cell. So which is a new node created. So we call it as temp cell. So what is temp cell? We have to allocate the memory for that. So malloc is an operator which is going to be used by C, which is create the allocation of memory for the particular node. So this is an integer list, 10 is an integer value. So 2 bytes to be allocated for this 10. So malloc, what is the size? So size of to be using here, then to be the particular node. So struct node. So the temp cell, it's a memory allocation to be done. What is the size for node? So this is a node, we are creating 10 is a 2 bytes. So with the memory compiler is now understand to be identified for M allocation operator to be 2 bytes is allocated for this node. So node means which consists of the data value on the pointer, which is called temporary cell. So now it's created. Now what happened? We are changing the pointer of this 4000 to be the next position, and the data part of this node is 10. So temp cell data or element, it's X. So X is our element, X is 10. Now the first compartment is filled by X. So this is a pointer parameter, the arrow is distinguished, that is the arrow parameter for pointer. What is the next pointer to be used? Then the next pointer, this position. So this position, it's a temp cell of next to be on position of next. So what is the position of next? So this is now, it's a next, the initial value is in 4000. So you have to set the 4000 to be on the particular node. So temp cell of next is equal to position of next. So the values now, the pointer value, the memory locations to be stored in the 4000, it's a newly created things. So now this is a pointer allocation. Now this is position of next is equal to temp cell. The position of next is equal to temp cell. So newly created temp cell now is allocated to the position of next. So initially head inserted first, we are going to be inserting the value. So this is a code for inserting at the element into the linked list. So inserting, we need the data part and the pointer value, and we have to adjusting the pointer to be inserting one element. So this is the values or to be using for linked list. This is it's not to be using for the traversing from the beginning. You can you can traverse when you are knowing the values, right? So this is insertion in linked list. So now we go by stack ADT. So linked list is very simple, which has a lot of advantages. Random access, the linear search to not be performed, we can easily finding the particular position. When you are finding from this linked list, once you know the position, it's going to be traversing anywhere. So comparing to array, linked list having many advantages for the execution time, which is very less execution time for finding, insertion and deletion to be made. Right. So now we are going to be seen of stack. Stack is another ADT like linked list. So stack is also implemented via the linked list. So this is also is a non-linear data structures. So what is stack? So we have the insertion and deletion at only one end. You cannot perform on different position as like a linked list. So insertion and deletion performing at one end, we call it as top of stack. So top of stack is the position we have to performing the insertion and deletion. What is the preliminary operations of stack is push and pop. So push is for insertion, pop is for deletion. So which is we call it as lost in first out. So lost in first out means when you are lastly enter, which is extracting from the stack at first. So the top of the stack, what is the element in the top of the stack that is going to be extracted from the stack? So what is that? You have 6, 2, 3, 4. That is element 6, 2, 3, 4. So consider this is a stack. So now 6 is inserted. Right, so 6 is now giving this position and 2 is inserted the next position, then 3 is inserted next, so 4 is inserted first. So this is top of stack. So 4 is a last element, but which is occupy the top of the stack. So once you are removing, and this is the first element to be extracting from the stack. So now we are performing pop. This 4 is first is going to be extracting from the stack only 3, 2, 6. So what happens is a lost in first out, lastly inserted element, it's extracting from the stack at first. So 4 is a last element, it is inserted, but when you are performing pop operation, the 4 its first is going to be outing from the stack. So stack is very easy to perform via linked list. So push and pop is a 2 operations instead of insertion and deletion in linked list. So what are the applications of stack? So applications of stack, there is 2 primary applications. One is evaluation of postfix expression. And it's a conversion of infix to postfix. So evaluation of postfix expression and infix to postfix conversion. What is postfix infix? So when you are writing a plus b, so this is operand, a and b is operand, plus is operator. So this is infix. Between the operands we have placing the operators, which is called infix expression. So what is postfix expression? So after the operand a and b, we are denotifying the operator, that is we call it as postfix. After the operand we are placing the operator plus. So lot of execution and evaluation is done by the postfix expression. Like C programming languages, all the expression can be evaluated via postfix. The first one is the evaluation of postfix expression. The postfix expression what we are taken here, that is 6, 5, 2, 3, it's plus 8 and star plus and 3 plus star. So this is some example of evaluation of postfix expression. So this is postfix. After the operand we are placing operator. So it's always end with the operator. So 6, 5, 2, 3 plus 8, it's a multiplication, and plus 3 plus star. So now we need the actual evaluation of this postfix expression. So we are implementing via stack. So first stack is to be implemented, right? So all the operands, when you are reading starting from the first position, you are going to be reading every operand. If there is an operand, have to be pushed into the stack. So push is the insertion. So first 6 you are going to be inserting first, then 5, then 2, then 3. So now the compiler reads the operator plus. So what has happened? If the plus is reached, so immediately it's performed the pop operation for 2 operands, because all the operators need to be evaluated via 2 operands. So 3 and 2 to be pop. So first 3 and 2, because top of the stack, what is the element is going to be in server to be extracted. So 3 is the top of the stack. After 3, the top of the stack to be moving to the 2. So the element 2 is also to be performed. So now the value is 5. So after plus, what is the stack value? It's 5, 5, 6. So after execution, the 5 is pushed into the stack. So now top of the stack is incremented here. T is incremented here. So next is 8. 8 is operand. How to insert it into the stack? So 8, 5, 5, 6. So 4 elements in the now. So now the top of the stack is 8. So now it's a reading of operator. So what happened? Once you are reading operators, you have to perform 2 pop. So 8 and multiplication with 5. So now the top of the stack is come here. These 2 elements is extracting from the stack. So 8 into 5 is 40. Again 40 is pushed into the stack. So 40, 5, 6. The 40 is the top of the stack. So now plus. So plus again the same operation is to be popping 2 elements from the stack. So 40 plus 5. So 45. So 45 is now pushing into that. So 45 and 6. The stack is now with the 2 elements 45 and 6. Now what is the next element? Is 3. So 3 is now pushed into the stack. So now 3, 45, then 6. So now here it's the top of the stack. So now we are reading the operator plus. So plus is read now. So what happens? Popping from the 2 elements 3 and 45. What is the resultant value? It's a 48. So 48 again is pushing into the stack. So 48 and 6. So what is the last operator? It's a multiplication. So multiplication, then popping 2 elements 48 into 6. So what is the value? Is 288. So 288 is the final value. There is no other operands and operator. So this is end of stack, end of evaluation. Finally, the postfix expression for this one, its evaluation is done by the value 288. So this is evaluation of postfix expression via stack. So when you are seeing the operand, you have to pushing into the stack. When you are seeing an operator, you have to pop 2 elements, because every operations we need 2 operands. So popping the 2 elements and evaluate, and the final resultant to be pushed into the stack, then the final one we have to use. If given postfix expression is wrong, we are not getting the absolute value of 288. If any one of the operators is again comes here without any operand, then this is a wrong postfix expression. Sometimes they can ask of the a false postfix expression to be evaluated. We cannot evaluate false postfix expression. So this is one of the application using stack evaluation of postfix expression. So when you are popping, very simple, top of the stack is to be decremented. When you are pushing, the top of the stack to be incremented. And another condition need to be checked when the empty stack is there. So there is no element in the stack, we cannot perform pop, because empty elements, there is no element to be available to be pop, extracting. So it causes errors. So similar, when the size of the stack is complete, its size of stack is 4. So already there is 4 elements in the stack. But now you are going to be pushing another element 10, which is not possible, which is also causing error. So when it's meet the size of the stack, you cannot perform push. The capacity once is going to be increases when you are popping, then only the another element to be inserted. The stack is very simple. So pushing operation to be the specific location to be available, the capacity permit to be pushing the operation. If the size of the stack is full, we cannot perform push. And when the size of the stack is empty, you cannot perform pop. We need some element in a stack to be pop. Then the top of the stack, when you are pushing, you have to increment it by 1 by stock. When you are popping, the decremented by top of the stack. The insertion and deletion at the one position, that is top of the stack. That is not from the another position. The next one, the last application of stack is infix to postfix conversion. So infix to postfix conversion. So previously what we see, it's a postfix expression is given an input, we can evaluate the postfix expression via stock. Now what they are given, it's a given is infix. You have to convert it with the implementation of stack to be converted to postfix. So what is the infix expression? What we have taken, that is A plus B star C, then plus, so within a parenthesis, that is D star E plus F then multiplication of G. So the infix expression, what has happened? So operators between the operands. So plus is between A and B, multiplication is between B and C, and plus is between C and which is some set of operands. So which is, we can easily say this is infix operation. So infix expression. Now we are going to be converting this infix expression into postfix. So a lot of rules to be applied to be converted this one. So what is that? We have two window on implementation. One is stack, another one is output window. So what we have to do, the first, when the compiler sees the operand, immediately it moves the operand to the output window. When it sees the operator are pushed into the stack. So operand are segregated to the output window, operators are segregated to the stack. So let's see what is happened on infix to postfix conversion. It's always start from the first position, A, it's a compiler determines its operand, so it's moved to output window. So A is in output window. So now next one is plus. So plus is an operator. So immediately what happened? We are pushing the plus to the plus. So plus is to be pushing into the stack. So now the third one is a B. So B is an operand. So we are going to be moving to the output window. Right. So now what is fourth one? It's 4. So fourth position is a multiplication. So now we have to check some condition. Now we have the operator multiplication. We go by the precedence rule. What is precedence rule? What is a precedency? The multiplication having higher priority than plus. The multiplication division having the higher priority than plus and minus. So once we are checking the operator, if the stack operator, what is the operators in stack which is have the highest priority than multiplication, you should perform pop from the stack. So now the stack is in plus. Now the incoming operator is multiplication. But what is a stack operator precedence? Plus is having very less priority than multiplication. So there is no problem on second step. We can directly pushing multiplication into the stack. So now the output window is A and B. Right. So now what is the next value? It's 5 is C. So C is directly moved to the output window. So what is the next one? It's plus. So now incoming operator is plus. How to check it out? The operator in stack. So plus and multiplication. What has happened? The multiplication having highest priority than plus. So now we have to perform pop. So pop operation to be performing, because the inside the stack what operators having which is highest precedence, then we have to pop this operator and place it into the output window. So now is plus is incoming, the multiplication is highest precedence, so now we are popping the multiplication temple to the output window. So now this multiplication is moved to output window. Right. So now this is pop. So now this plus is again checking to the another operator is plus. So which is not highest? Plus and plus are equal. When there is a equal, again the operator to be popping that. So very simple. When you are comparing the operator, when the inside the stack operators having highest or equal precedence, immediately you have to perform pop. So popping from the stack and placing into the output window. Now this plus is popping and we are placing into the output window. Right. So now stack is empty. Now this plus to be pushing into the stack. Right. So this is a scenario of comparing of the operators in stack and output window. So what is the seventh one? It's a left parenthesis. So left parenthesis is not an operator. It's a having some group of elements, but which is have very highest precedence. But when you are performing that, for example, this is not possible. So this is left parenthesis. Consider. So this operation cannot be evaluated. The left parenthesis not having at all anything about the evaluation. A left parenthesis, B we are not going to be evaluated. But this is having the come set of element. So this is wrong. So when you are seeing the left parenthesis, when it's come left parenthesis, you simply pushing into the stack. So left parenthesis now pushing into the stack. So once left parenthesis is inserted, then when it's come the right parenthesis, up to that you have to remove from the stack. So in one by one. So now after the left parenthesis is D. D is our operand. We have to move to the output window. So D is now moving to the output window. So now is a multiplication symbol. So multiplication symbol and this is left parenthesis. We do not check because which is having the different features of left parenthesis and multiplication. We are simply pushing the multiplication symbol into the stack. So now So 10th one, it's E. So E is a operand. What happened? How to simply go to the output window. Now plus. So now plus is to be coming to the things. So now already there is an operator. So plus and multiplication, which is highest precedent, that is multiplication. So multiplication should be now popping to the output window. So now this multiplication, it's moved to this output window. Right. So now what are the operator? Left parenthesis. Left parenthesis and plus cannot be matched. So we cannot be compared. So now plus is to be pushed into the stack. So now it's 11. So now 12 is F. So F to be now operand, how to output window, move into output window. Right. So now the 13th token is right parenthesis. So when the right parenthesis, it's coming to the stack. So what happened immediately stack? So once left parenthesis to be removed once receiving the right parenthesis. So now this group of elements is over. So what happened? Immediately have to pop up to the left parenthesis. Once the compiler sees the right parenthesis, up to the left parenthesis, what are the operators inside that? Have to moving to that output window. So pop the operators and to be moving to the output window. So parenthesis to not be in the output window because it's not an operator. It's kind of it's a set of elements to be identified. We cannot perform any manipulation. So this is pop, this is thrown away, then plus to be output window, then left parenthesis is also to be thrown away. So this is pop. Now this three elements in stock is pop. So plus is go to the output window. So now there is a 14th one, it's a multiplication. So multiplication arises, what happened? It's plus, it's very lower precedence than multiplication. So no problem. So multiplication to be pushed into that pop. The final is a 15 is G. G is an operand. So we have to move to the output window. So now there is no other element. It's the end of token. So what happened? Still the stack is having two operators, star and plus. So there is no other input. So immediately have to pop all the operators in stack to the output window. So first, the last in first out. So multiplication is moved to output window first, then plus. So this is the answer for the infix to postfix conversion. So given input infix expression, what is we are converting via the stack implementation, that is A, B, C multiplication plus D, E multiplication F plus G star plus. So this is the postfix expression for the given infix expression. It may be given by numbers or any other variables. It's not to be alphabet ABC. Instead of ABC, they can given any value of 10 for any numerical value or floating parity value also to be given. So very simple how to identify some of the rules of the infix to postfix conversion. So when it's operated, operand is incoming input, you have to move to output window. When it's operator, have to move pushing to the stack. But when two operators are to be coming to the stack, have to check the precedence. If the highest precedent operator is in stack, then immediately have to pop into the output window. So no parenthesis to be placed on the postfix expression. So other than the arithmetic operations and operators, so no other special symbols like curly braces and open parenthesis, square brackets, these are all, it's outside the operation, so we are not going to be considered in a postfix expression. So this is the application of stack. So stack is the insertion and deletion, that means push and pop perform at one end, that is top of the stack. The application, various places we are for stack ADT to be used for the evaluation of postfix and this infix to postfix conversion. So the list ADT, linked list ADT and stack ADT. List is a linear which is very contiguous, and the linked list is a non-linear and stack is a non-linear. So whenever you are performing some operation behind the algorithm, you are going to be providing solution for a particular problem. You can choose this kind of data structures which is very useful to you. So this is about all data structures and algorithm of simple concepts we are taken is ADT. So once I recall, so what is ADT? What is the types of ADT? What is data structure? What is an algorithm? And what are the types of algorithm are there? So various operations can be performed in array, list and linked list and stack. We can perform everything. So lot of structure to be used. So data structure very preliminary. Whenever you are writing the program, you need to be considered about data, because we all have data. I am Mannivanan, I am having the name and I have the number and I have the address. So once we are defining myself, we have the different data types. So you go by the computer, the data should be handled very efficiently. We do not want to waste the memory, because main memory, which is the RAM, is having very less memory. So once I conclude, this is a data structure session. I hope this session is very useful to you for understanding the concept of basic data structures and algorithm. Thank you.